Hello and welcome to another session of Streaming School. Thank you so much for joining us again. It is wonderful to have you here with us, and we're lucky enough to have is this our fifth session of the day, Nish?
Yeah.
Yeah, our fifth session of the day with another wonderful science lesson focusing on chemistry with Ms. Bucky Youssef. How are you, Bucky?
I'm good, thanks. Really surprised it's the 1st of May. I think to myself, where did April go? So I'm a little bit of shock about that, but yeah, in a good place, thank you.
Wonderful, wonderful. Well, whenever you're ready to share your screen,
all right then.
Please let us know and we'll get away with another lesson.
Okay, thank you so much.
Have you heard anything from your school about potential dates or times or anything?
No, not yet. All we're doing is just keeping an ear out for any government updates, but making sure that we have a number of different contingency plans in place to enable our students to transition back from, experiencing teaching and learning on a remote basis back into in the classroom. And because our students have complex learning needs, we need to make sure that we minimize any uncertainties and anxieties. So that's what we're just thinking through.
Crazy. Absolutely, yeah. It's just, I think that the support that teachers need right now is, we've seen the pressure's been on the NHS. Hopefully, if we were over the peak, as the Prime Minister said yesterday, it's a wave. But our teachers, educators, and parents throughout are going to need all the help coming forward.
Absolutely, yes, I definitely agree.
All right, brilliant. It is on your screen.
All right then. Okay, so I need to just do this really quickly. I've done something really quickly. Okay, so hi everybody. This is the 6th lesson of chemistry. Actually, times have gone really quick, and it's also the 1st of May as well. So it's really interesting to see how quickly time's gone. I've just changed things up a little bit because we've got some quite challenging concepts to cover today. Rather than have a recap, I thought we'd just go straight into the quick 5-5. And for those of you that are joining me for the first time, the quick 5-5 gives an opportunity for you to review any prior learning and just a quick recap. So if you've got your exercise book or even a sheet of paper or device, you write down just numbers 1 to 5 and write a one or short sentence answer to each of these 5 things. And then I would normally pause. So if you are watching this in your own time, pause for about 3 to 4 minutes, jot down your answers, and then continue with the lesson to hear what the answers are. So let's just go through the answers right now. So number 1, what is the atomic number of an atom? And this tells you the number of protons or electrons an atom has. How many groups are there in the modern periodic table? And it's 8. So this just to give clarity to my previous lesson, where if you look at textbooks or go online or look at websites where it mentions 18 groups, actually for the modern periodic table, if you cover this level of knowledge at GCSE level, you only need to be aware of the fact that there are 8 groups in the periodic table. What is the electronic configuration of magnesium? So to help you answer this, you need to know the atomic number of magnesium, how many electrons it's actually got, and think about how you'd represent that as a series of numbers separated by commas. And this is what it represents. 2 means that there are 2 electrons in the inner shell, the electron shell that is closest to the nucleus, and then 8, and then 2 electrons in the outer shell. State the relative charges of subatomic particles. Subatomic particles mean the parts that an atom is actually made out of. And if you remember that correctly, it's protons, neutrons, and electrons. Protons have a positive charge of +1. Neutrons have no charge, 0. And electrons have a negative charge of -1. And lastly, question number 5, what is the relative formula mass of the compound MgO2, magnesium oxide? To work out the relative formula mass of a compound, you need to look at the atomic masses of each element that you see. So in the answer, you've got magnesium's atomic mass is 24, oxygen's atomic mass is 16, but you'll notice that because there's a small 2 next to the oxygen, it means that you've got 2 oxygen atoms in the compound, and you add them together to give you the relative formula mass of 56. Okay, so today's lesson is focusing on ionic compounds. And we're going to be looking at, it just says the chemical and physical properties of ionic compounds. We're actually going to look at, get clarity about how ionic compounds are actually made. So the do now question says, explain how an ion is different to an atom. And if you're not sure of the answer, then look at this hint box where it shows you a lithium atom next to a lithium ion. How would those two particles actually different from each other. The challenge questions are: which ions do group 1 elements form and why do they form that? Which ions do group 7 elements form and why do they form that? And the key words, there are a number of different keywords that we're going to be looking at and using in today's lesson. So with the do now answer, again, with the diagram that I gave as a hint, when you look at the lithium atom, if you were with me last week lesson, you'd see that the positive protons are represented here and the negative electrons are represented by the yellow circles. And you'll see that with the lithium ion, one of those electrons is actually gone. And this is just to remind us about the fact that in order for an atom to become an ion, whether it's got a positive or negative charge, they have to lose or gain electrons. And in lithium's case, it has lost an electron, hence the overall positive charge, which you see when you write down the formula for the lithium ion. So just to remind us about the fact that if you look at this in terms of the context that you would have covered, there are different types of chemical bonds. You can have ionic bonds, covalent bonds, and metallic bonds, but today we are specifically looking at ionic bonds. Now there's a whole load of blurb on this page. It's quite a lot of information, but I'll quickly summarize. Ionic bonds are only made between metal elements and non-metal elements, and the electrons move from the outer shell from the metal element to the non-metal element. If an element actually loses an electron, it becomes positively charged, and if an element gains an electron, it becomes negatively charged. Now, some people find that confusing because the misconception is some people think that when you gain an electron, you actually become negatively charged. But you need to make sure that you remember that any element that actually loses electrons actually becomes positively charged, and any element that gains electrons becomes negatively charged. Now, because of these charges, we say that the force of attraction, we describe it as strong electrostatic attractions, basically strong attractions between the positive and the negative charges on the ions. And because these attractions are so strong, ionic compounds have very high melting points and they have very high boiling points. Now, think of it as magnets. So I've just given you a diagram there. Where you have magnets that have the same poles, so north going to north, they actually repel from each other. Where you see in the third diagram, the north pole that goes to the south pole, the attraction is so strong. And if you've ever used a magnet before, you know how difficult it is to pull that the poles apart, so the magnets apart, when they've actually got opposite charge, opposite poles that are attracted to each other. So the same principle happens with ionic bonds. Okay, so just to recap some of the key words. So electronic structure, what you need to think about are the number of electrons, the atomic number of an element, and think about where those electrons go. So just recapping from last lesson, that the first electron shell, also known as the inner electron shell, is the electron shell that is closest to the nucleus, and it can only take a maximum of 2 electrons. And the outer shell can take up to 8 electrons. So you can see the lithium atom, it's got 3 electrons, and this is its electronic structure. So you're physically showing where the electrons go, and the electronic configuration just shows you a numerical representation of where those electrons are. If we go from atoms to ions, again recapping, so an atom becomes an ion when it loses or gains electrons. So again, with this diagram, becomes stable, the lithium atom actually loses its electron, so it then becomes Li+, and you've only got 2 electrons in the outer shell. Let's do this for another element, so like fluorine, again, to recap the previous lesson. So fluorine has got 9 electrons, and if we draw its electronic structure, you have 2 electrons in the inner shell, which is closest to the nucleus, and the remaining 7 electrons go in the outer shell. That's its electronic structure, and its electrical configuration is 2, 7. It's really important to put the comma there because that represents the electron shells and how many electrons are in each one. So if the fluorine atom becomes a fluoride ion, its name, not only does its name change, but the electrons that the lithium atom, represented by the yellow electron here. So the yellow electron that the lithium atom lost is actually gained by the fluorine atom to become a fluoride ion. And its configuration actually shows that there's a change. So rather than being 2, 7 for the atom, that 7 has become an 8 because it now has an extra electron in its shell. Okay, so I've been speaking for quite a bit, but it's really important you understand those key concepts. So if you're not sure about how the atoms become ions, please recap and revisit the previous Activate pages. But let's have a progress check. So you've actually got 2 progress checks today, just to test and demonstrate your understanding. So I'd like you to draw the electronic structure and electronic configuration for sodium, which is an alkali group 1 metal, and chlorine, which is a halogen, and it's a gas. So you've got visual images to show that sodium's a metal and that chlorine is actually a gas. If you aren't sure about where to start, look at the hint tips. What is the atomic number of sodium for sodium, and what's the atomic number for chlorine? Pause at this moment if you are watching this in your own time. Give yourself a couple of minutes, and then press play to continue to see the answers. Okay, so as always, you need to think about the atomic number. As I said, for sodium, 11 electrons. So its electronic structure, this is what we do. And the electron configuration shows it's got 2 electrons in its inner shell, 8 in the next shell, and 1 in its outer shell. That 1 also tells you which group it belongs to in the periodic table. So 1 electron in the outer shell means it's a group 1 element. If we look at the answers for chlorine, 17 electrons, 2 in the inner shell, or the first electron shell, 7 in the second electron shell, and it should be another 7, so it's a little bit slow. So the electronic configuration for that is 2, 8, 7. And again, this is an important aspect that you need to make sure that you can understand. You can draw the electronic structure for any of the first 20 elements in the periodic table, and also the correct corresponding electronic configuration. So if you're not too sure at this point, please make sure that you practice. Okay, so progress check 2. Draw the electronic structure and electronic configuration to show how sodium and chlorine atoms become ions. Okay, so the hint is that in order for the elements to be stable, electronically stable, they need to have 8 electrons in its outer shell. So what do you need to do in the element? Does it need to gain electrons to get that 8, or lose electrons to get that 8 in its outer shell? Okay, so sodium atom, this is what it looks like. It's got 11 electrons. You'll notice that the atom and the ion are slightly different. The ion has a positive charge. So for that to happen, it means that the outer shell electron is lost, and the electron configuration is different to the atom. So it's 2, 8 to show the electron has been lost. If we look at the same for chlorine, the atom to the chloride ion, again, the chlorine atom, the chemical symbol for that is Cl. Please note this is a lowercase l, not an I. Sometimes some people think it is. The chloride ion has a negative charge, it's El minus. And that negative charge means that it gained the electron that the sodium atom lost. And this is also shown by the change in its electronic configuration. It is now 2, 8, 8. The 8 in the outer shell shows it has gained an electron. Okay, so just to summarize and recap, group 1 elements react with group 7 elements. And when they react, group 1 elements lose an electron. So each of these elements that are listed here, apart from hydrogen, they lose an electron. This electron goes to the group 7 elements listed by, as I said, I've indicated with a red box here, and they both achieve the electronic structure of a noble gas. And because it's group 8, and I said before that the number of electrons in outer shell tell you which group it is, group 8 elements have 8 electrons or a stable and full outer shell. Okay, now this is quite a common topic to have in exam, and it's also a common exam question a lot of students find really difficult to answer. So let's just explore how you could actually answer this 4-mark question. Explain how an ionic bond is made. So just recapping what we've looked at in today's lesson and thinking about how you can actually use those keywords from the start to explain an answer that's worth 4 marks. So just to break this down, whenever we see the word explain in an exam question, it basically means to write a point and to give a reason or explanation for it. And as I said in previous lessons, for those of you who joined me before, whenever you think about your answers for exam questions or lengthy questions, think about the key words that you need to include. Think about the sentences or the key points that you're going to write down for each of the marks that are awarded in the exam question, and make sure that your points are clearly explained. So, how do we do? Now, if you're watching this in your own time, again, pause. Generally, I say to pause for 1 minute for each mark. So it's a 4-mark question, pause for 4 minutes and see how well you can actually do. So let's explore the 4 key points that would actually get us the 4 marks. So if you said something along the lines about the fact that ionic bonding is a type of bond that occurs between non-metal atoms or elements, if you use the word elements, that's fine. Metal atoms and non-metal atoms or elements, then you'd actually get a mark. If you said something along the lines that the metal atom or element always transfers or gives its outer shell electrons to non-metal elements or atoms, then you get another mark. So you're clearly showing where the electron is coming from and moving to. If you need to say how the ions, the charge of the ion, so something along the lines that when the metal atom gives its electron, it becomes positively charged. And when a non-metal atom or element takes the electron, receives the electron, it becomes negatively charged. Now, if you do higher tier or more demanding exam questions, then the lilac box indicates something that you need to include in order to get the mark. Oppositely charged ions are strongly attracted to each other by electrostatic forces. And by electrostatic, it basically means the strong charges between positive and negative ions. And this forms the actual ionic bond. So, as always, reflection. What did you do well? And you can think about the progress checks as well. What have you done well? And what are the key things that you need to improve? As I said, this is quite a challenging topic for many students. So if you need to go through it again in your own time to make sure you understand it, then please take the time. It'll be well worth it. Okay, so familiar with my plenaries, 3 things that you remember. What are the 2 things that you're struggling with? Please take time to review that. And what will help you next lesson? And for further thinking, if you're not too sure about what the words period and group means in relation to the periodic table, and you want a little bit more detail about the 8 groups in the periodic table, then please look at the link that you see, care of Few School Global Education. Thank you very much, everyone, and have a good day.
Thank you so much, Bucky. Really, really appreciate it. What's the rest of your day looking like?
The weather?
No, what's the rest of your day looking like?
Oh, just admin, catching up on admin and things like that. And then looking forward to the weekends, even though it's the same as the weekday, but there you go.
That'll be changed soon. Do you think they'll lift it soon?
I don't know. I'm not even going to speculate. I don't know, because sometimes I think soon. I'm not sure. I think next month, maybe give it another few weeks and we'll take it from there.
I was walking past and the radio was on, and I heard Boris Johnson talking yesterday evening, and it just sounded like he was trying to make it sound like it was a really good thing. And so I was just waiting for him to go, and the lockdown's lifted, and you can all run about again. I think 2 more weeks. I think 2 more weeks, and I think people will have more freedom of movement. But there'll be a partial lockdown in some way for certain aspects of society or certain stores for a very long time. Like football isn't, you're not going to a football match this year. You're not going to a football match before a vaccine.
Okay, well, we'll see. As I said, I'm not going to speculate because I think with the call that speculation about schools going to go back soon and the anxiety it caused, I just thought I'll just take it as it comes and just remain calm in the meantime.
Wonderful. Have a great.
Okay, thank you so much. Take care. Bye bye.
Thank you very much, Nish. How are you back with you, my dear?
Yes, all right. So when it loads, I have the optional task for chemistry today. So there are 2 questions. Number 1 is, what are the main properties of ionic compounds? And number 2, how does the periodic table work?
Brilliant.
If you've missed out any of the sessions on Facebook and YouTube, and now we have a mindfulness session.
Yes, we do. A very warm welcome to our very dear friend Trevor. Very good morning to you, Mr. Benstock. How are you?
Hi, I'm good, thanks. How are you two doing?
Yeah, really well. Thank you, buddy. Really well. So what we're going to do is we are going to cut this stream so it sits nicely, and that you, Bucky has her lesson on your own. You have your lesson on your own. Please stay with